Hello and welcome to this lesson on encrypting data at rest and data in transit with the file storage service. I am Mahendra Mehra, your senior OCI instructor with Oracle University. Let's get started. In the realm of file storage service for provisioning persistent volume claims, the distinction between at rest and in transit encryption is crucial. By default, the service ensures data at rest is always encrypted using Oracle managed encryption keys. For those seeking to manage their own at rest encryption with personal master encryption keys, the process varies based on whether you are provisioning a PVC on a dynamically created new file system or an existing manually created one. To embark on managing your own keys, the steps involve creating a suitable master encryption key in OCI Vault or obtaining the OCID of any such key and establishing a policy to grant access to the master encryption key. To use a master encryption key from the Vault service to encrypt data in file systems, you must use the following policies. The first policy is to allow service FSS realm key prod to use keys in compartment where you specify your compartment name, where target.key.id is set to the OCID of your master encryption key, where FSS realm underscore key prod is the name of the file storage service user. The name of the file storage service user depends on your realm. For more information about Realm, you must visit the regions and availability domains official documentation. Compartment name is the name of the compartment containing your master encryption key, and key OCID is the OCID of the master encryption key within the vault. Another policy that you must set up is to allow any user to use key delegates in compartment where you specify the compartment name, where all request.principal type is set to cluster and the target.key.id is set to the OCID of your master encryption key. This allows your Kubernetes cluster to use key delegates within the compartment where your master encryption key is present within the OCI vault. Additionally, the file storage service offers optional in-transit encryption. If specified, data in transit is encrypted using Oracle managed TLS certificate, irrespective of whether the data at rest is encrypted using Oracle managed or user managed keys. To configure in transit encryption, the method varies depending on whether you are provisioning a PVC on a dynamically created new file system or an existing manually created one. The service provides users with the flexibility to tailor their encryption strategies to meet specific security requirements. Now let's take a closer look at managing data at rest for a new file system dynamically created by the CSI Volume plugin. And we'll explore both options, Oracle managed keys as well as own master encryption keys. When aiming to encrypt data at rest on a new file system using Oracle managed keys, the process is seamless. The file storage service automatically encrypts data at rest with Oracle managed encryption keys. To initiate the encryption of data at rest on a new file system, the first step is to create the file system. In this scenario, we are utilizing the robust security of Oracle managed encryption keys. To create a new file system that uses Oracle managed encryption keys to encrypt data at rest, we must go to the OCI file storage service, and under the create file system window, we must select the encrypt using Oracle managed keys within the encryption setting. Once you create a file system with the encrypt using Oracle managed keys enabled, the next thing is to set up the storage class definition file. As you set up the storage class definition, you must ensure not to include the KMS key OCID parameter. By doing so, you seamlessly leverage the default encryption capabilities provided by Oracle, enhancing the protection of your data at rest. For those opting to encrypt data at rest on a new file system using their own master encryption keys managed in the OCI Vault service, a straightforward procedure is available. Firstly, create the new file system using the option of encrypt using customer managed keys. This signifies your intent to utilize user managed keys for encryption. Within the OCI file storage service, when you create the file system, under the encryption setting, select the encrypt using customer managed keys option, and under the vault compartment, select the compartment where you've created the vault. Under the vault field, specify the vault. Then under the master encryption key compartment, select the compartment where your master encryption key is created, and under the master encryption key field, select the MEK that you had created. Once you create a new file system with the desired setting, the next step is to set up your storage class definition file, where you particularly set up the KMS key OCID parameter and specify the OCID of your master encryption key from the vault service as its value. To wrap up, in this lesson we covered how to set up encryption for data at rest and in transit on a new file storage service using the Oracle managed key as well as user managed keys. I hope you found this lesson useful. See you in the next one. Thank you for watching. Welcome back, and let's continue with the lesson on encrypting data at rest and data in transit with the file storage service. Let's now take a closer look at how to encrypt data with file storage service at rest for an existing file system that you have manually created using the Oracle managed keys and the self-owned encryption keys. To encrypt data at rest using Oracle managed encryption keys, you should follow the steps in provisioning a PVC on an existing file system. These steps are already covered in one of our previous lessons. Once you provision a PVC on an existing file system, you must simply select the encrypt using Oracle managed keys option, and the service will seamlessly encrypt your data at rest using the encryption keys managed by Oracle. For an existing file system, one must ensure that the encrypt using Oracle managed keys option is selected for the encryption settings. I'm already logged into my OCI account. Let's go to the file storage service. I'll click on the storage option and go to file systems. For your existing file system, you must ensure that you have selected encrypt using Oracle managed keys. To do that, I'll existing file system that you have manually created using the Oracle managed keys and the self-owned encryption keys. To encrypt data at rest using Oracle managed encryption keys, you should follow the steps in provisioning a PVC on an existing file system. These steps are already covered in one of our previous lessons. Once you provision a PVC on an existing file system, you must simply select the encrypt using Oracle managed keys option, and the service will seamlessly encrypt your data at rest using the encryption keys managed by Oracle. For an existing file system, one must ensure that the encrypt using Oracle managed keys option is selected for the encryption settings. I'm already logged into my OCI account. Let's go to the file storage service. I'll click on the storage option and go to file systems. For your existing file system, you must ensure that you have selected encrypt using Oracle managed keys. To do that, I'll first select the file system. We can confirm from the file system information tab that the encryption key has been set to Oracle managed key. If not, you can always click on edit and you can choose from the options available. In this case, the desired option is already selected. There's nothing to do. But just in case the desired option is not selected, you can change it from this position. Alternatively, for those desiring the added control of user managed keys, the process involves selecting the encrypt using customer managed keys option during PVC provisioning. And within that option, you must specify the master encryption key from the vault service to encrypt data at rest. In this example, the file system is using Oracle managed key for encryption. I'll go ahead and click on edit and choose the encrypt using customer managed keys option. When I select this option, the window expands and asks us for the vault's compartment. You must select the compartment where your vault resides and then select the vault from the given compartment. You must then select the master encryption key compartment and ensure that you select the master encryption key that you wish to use for encrypting data at rest. With this, we come to the end of this lesson where we saw how to encrypt data at rest on an existing file system using Oracle managed keys and self-managed keys. I hope you found this lesson useful. See you in the next one. Thank you for watching. Hello and welcome to this lesson on encrypting data at rest and data in transit with the file storage service, and this is the last lesson in this series. Let's get started. Now let's delve into the imperative topic of encrypting data in transit on a new file system dynamically created by the CSI volume plugin. Firstly, it's vital to understand that in-transit encryption secures data as it moves between instances and mounted file systems, employing TLS 1.2 encryption. Notably, the TLS certificate for in-transit encryption is always Oracle managed, regardless of the encryption state of data at rest. A key consideration is that in-transit encryption is supported only when the compute instances hosting worker nodes are running Oracle Linux 7 and Oracle Linux 8. To set up in-transit encryption for Linux, a series of tasks need to be accomplished, starting with downloading the OCI FSS utils package, followed by its installation on an Oracle Linux or CentOS, and then you must include security rules that must be configured to allow TCP traffic on port 2051 for both ingress and egress traffic. Lastly, to enable in-transit encryption for the new file system, ensure to include the encrypt in-transit parameter and set its value to true in the storage class definition. Now let's look at how to encrypt data in transit on an existing file system. Encrypting data in transit on an existing file system involves building upon the established in-transit encryption for Linux. The process remains consistent, ensuring the compute instances are running Oracle Linux 7 or Oracle Linux 8, and the security rules are configured for TCP traffic as discussed in the earlier slide. However, for existing file system, the distinction comes when defining a persistent volume. The critical step is to set the encrypt in transit parameter to true in the CSI section of the manifest file when creating the persistent volume. As you can notice on the screen, we have a manifest for persistent volume, and under the CSI section, we have defined encrypt in transit and set its value to true. This adjustment ensures that the existing file system benefits from robust in-transit encryption. In summary, the file storage service in Oracle Cloud Infrastructure empowers users to fortify their data security strategy comprehensively by seamlessly encrypting data at rest using Oracle managed or user managed keys and employing TLS encryption for data in transit. The service provides a versatile and robust framework for safeguarding data integrity across both new and existing file systems. I hope you found this lesson useful. Thank you for watching. Welcome to this lesson on DevOps IAM policies. As we all are aware, each service in Oracle Cloud Infrastructure integrates with IAM for authentication and authorization. The first step in setting up your DevOps service and project is creating the appropriate IAM policies for users, groups, and resources taking part in it. Before you begin using the DevOps service, you must meet the certain prerequisites, which includes creating users and assigning them to groups that can manage DevOps services. Alternatively, you may also choose to add existing users to the group. The next step is to create dynamic groups for DevOps resources like code repositories and build and deployment pipelines, as they will be interacting with other OCI services. For instance, the deployment pipeline will need appropriate access to manage target environments like compute instance group, OKE, or functions. The last step is to grant users permission to access the various DevOps resources. You must create IAM policies for user groups as well as dynamic groups. The policy statement must reflect who has what kind of access to various DevOps resources. Also make a note that by default, users in the administrators group have access to all the DevOps resources. For more information about IAM policies, you can review the OCI Foundation course and also follow the official Oracle documentations. These are the policy options for all the DevOps resources. The permissions listed here like inspect, read, create, update, delete, cancel, move are the atomic units of authorization which are pretty much self-explanatory. They control a user's ability to perform operations on resources. The purpose of verbs is to simplify the process of granting multiple related permissions that cover a broad set of access or a particular operational scenario. So as you go from inspect to read, use, and manage, the level of access generally increases and the permissions granted are cumulative. Resource type here specifies which all resources under the DevOps project can be controlled. Make a note to assign the permission to all the DevOps resources. Use the DevOps-family aggregate type. You can create groups, dynamic groups, and policies using the OCI console and use either the policy builder or a manual editor to create policies. This is the syntax for creating DevOps policies based on standard IAM policy syntax. First, you create dynamic groups, then you provide them the needed permissions. Although you can create a single dynamic group for all the resources types listed here, as you can see from the examples, we have created dynamic groups for DevOps repository, DevOps build pipeline, and DevOps deploy pipeline. You can group them together, but my advice here will be to have separate dynamic groups for each resource type as it gives you more granular control in terms of managing access to the resources in the compartment or tenancy. Later, once the dynamic groups are created, you have to provide policies or write policies to allow those dynamic groups to manage those resources that you wish to in a particular compartment. Let's take a look at a couple of examples for creating DevOps policies based on standard IAM policy syntax, which is essentially to allow a user or a pipeline to perform an action on a resource type in a given location. Dynamic groups have been created named Code Repo Dynamic Group and Build Dynamic Group. They are each being given permissions to manage items in a compartment. Note that the Code Repo Dynamic Group is allowed to manage all the resources of DevOps family in the compartment. To wrap up our discussion, in this lesson we understood the integration of DevOps services with that of IAM. We also covered the list of DevOps resource types and associated permissions. I hope you found this lesson useful. Thanks for watching. Hello, my name is Mahendra Mehra And as part of this demo, I will be showing you how to configure groups, dynamic groups, and IAM policies required to interact with the OCI DevOps services. Kindly make a note, in the interest of time, I have already set up prerequisites that would be required for us to move on with the demos. These are basics of OCI services which we expect you to be already familiar with. And I'll be talking about them as we progress through the demos. Alright then, this is our OCI console and I've already logged in using my credentials. So the first thing that we have to do here is create a dedicated compartment to host our DevOps resources. And I have already done that. So let me quickly show you by clicking on this hamburger icon and going to the identity and security option over here. If I click on compartments, so I have a compartment. The parent compartment is Mahendra, and within which I have created a sub compartment which is the CTDOC compartment. This is the compartment where I'll be configuring all my DevOps resources. Alright, so I have a compartment called CTDOC where all my DevOps resources will be configured. And this is a sub compartment for the parent compartment Mahendra, as you can see from here. Right. So one thing that you must do is make a note of the OCID for this compartment. So the OCID for my compartment is this over here as I've highlighted, and I'll be making the note of the same so that we'll be using this OCID while we create policies. Alright. Our next step will be to define a group of users. We will later use this group to create a OCI security policy that will allow the users to create, manage, and use the DevOps services. So in order to create the user, click on the hamburger icon over here. Go to the identity and security option and then click on groups. Click on create group and give it an appropriate name. So let's say I give it DevOps users group and give it a description. So let's say it's user allowed to run DevOps service by Let's click on create. Alright, my group is created. Now the next thing that I'll have to do is I'll have to add users to this group, the users who will be handling or managing those DevOps resources. So to add a user to this group, we will click on the add user to the group button over here. And then from the drop down, we'll select the user that we wish to add to this group. This is my user credential and I'll click this, click on add. And in no time, my user is added to the group. Our next task is to create dynamic group. Just a refresher, dynamic groups represents resources within OCI itself, usually based on resources in a compartment and can be further limited to a specific resource type. The larger picture requires us to create 4 dynamic groups for identifying the code repositories, the build service, the deploy service, and one for the DevOps connection in order to mirror external repositories. Alright, so to create dynamic groups, we'll have to go back to the identity and security service and then click on the dynamic group option over here. Now you can click on create dynamic group to start creating dynamic groups. Okay, so the first dynamic group that we're going to create is for the DevOps code repository. Let's give it a name, code repos dynamic group. Let's also give it a similar description. Now it's time to add the rules for the group. So the rules can be defined by specifying what resources are the member of the dynamic group. Also we can specify the compartment to which those resources belong. So for the code repos dynamic group, the rule is to specify that the resource type is of DevOps repository and it will be belonging to the compartment CTDOC. As you can see, this is the compartment ID of my CTDOC compartment. To create this dynamic group, click on create button. As you can see, I have created the rest of the 3 dynamic groups. So in all, we have 4 dynamic groups that we have created. One is for the code repository, the other one is for the build pipeline, the third one is for the deployment pipeline, and the fourth one is for the DevOps repository connections. Now let me quickly show you the rules that I have written in each one of them. Okay, for the build dynamic group, the rule that I have written is the resource type mentioned is as DevOps build pipeline and the compartment ID remains the same. That is my CTDOC compartment's ID. Similarly, for the other group, that is my deploy dynamic group, the rule is to specify the resource type as DevOps deploy pipeline, and again the compartment ID belongs to my CTDOC compartment. And the fourth dynamic group, that is for the connections. Again, the resource type is DevOps connections, and the compartment ID is that of my CTDoc compartment. Alright, now that we are done creating dynamic groups, let's go on to create policies. OCI security uses policies to determine what groups can do. We need to set up policies that will allow our groups to perform operations with OCI. Policies are applied in the parent of the compartment we are operating in. That is, the parent of the CTDoc compartment that I am using is Mahendra. So I'll be writing policies in the Mahendra compartment. Let me quickly show you that the compartment that I'm working in belongs to which parent compartment. So to do that, let's go to the compartments. Alright, so as you can see, we have a compartment called Mahendra over here, and within which we have our compartment CTDoc. So this is the compartment where we are managing all our DevOps resources, right? So the rules that we'll be writing is in the parent compartment of CTDoc, which is Mahendra. Let's jump to the policy page and start writing policies. To do so, click on the hamburger menu, go to the identity and security services, click on policies. On the left side of the page, locate the compartment selector, click in it and make certain that you have selected the parent compartment of the compartment you created. For me, it's Mahendra, so I'll be selecting Mahendra over here. And now you can start creating policies. Now you can start creating policies for the user groups as well as the dynamic groups that we have created. I'll create one policy for the user group, and there are 4 policies that I need to create for the dynamic groups. Click on create policy, and the create policy UI pops up where you can specify all the details. The first policy that I'm creating is for the DevOps users group. I've given it name DevOps users policy. Let's give a suitable description for this policy. You can enable the show manual editor and start writing your policies over here. So the policy that I've written is to allow group DevOps user group to manage the DevOps family in the compartment CTDoc. And if you recollect from the lessons, DevOps family is an aggregate type for all the DevOps resources. Click on create button to create the policy. Alright, this brings you to the policy page, and we can see that our policy is active now. Now go to the breadcrumbs and click on policies to start writing few others. Let me quickly create policy for the dynamic group. This policy that I am creating is for the dynamic code repo group. So I'll name it as DevOps code repo policy. Give it a valid description. And again, click on the show manual editor to start writing your policies. So the policy that I have written is to allow the dynamic group code repos dynamic group to manage all the resources that are present within the compartment CTDoc. Click on create to create this policy. As you can see from this page, our policy has been created and it's set to active. Let me pause the video here and create the remaining 3 policies for DevOps build pipeline, deploy pipeline, and DevOps connections. Alright, then as you can see, I have created the policies for other 3 dynamic groups, that is the build dynamic group, deploy dynamic group, and for the connections dynamic group. Let me take you to the build dynamic group policy, as the policy states that the build dynamic group is allowed to manage all the resources within the compartment CTDoc, and the resources that it will be managing are the build runners and triggering deployments. Taking you back to the other policies, in the deploy policy, as you can see over here, we are allowing the dynamic group deploy dynamic group to manage all the resources within the compartment CTDoc. Here the kind of resources that the deploy pipeline will be managing are the instance groups, the Kubernetes cluster, and the functions. Let's go back to the policies page, and we have the connection dynamic group policy. The policy written for this group is to allow dynamic group connection dynamic group to read secret family in the compartment CTDoc. So basically this particular group, dynamic group, the resources within this group will be able to read the secret value from the vault service in the compartment CTDoc. With this, I have completed the demo on security configuration to use the OCI DevOps services. I hope you found it useful. See you in the next demo. Hello and welcome to this lesson on DevOps projects and code repositories. The Oracle Cloud Infrastructure DevOps service is an end-to-end continuous integration and continuous delivery platform for developers. Whether developers are building a new cloud native application or migrating an existing application to OCI, the DevOps service is here to simplify their software delivery process. Using the DevOps service, developers can automate each phase of their software delivery lifecycle to release features more quickly and with fewer errors. The first step in building and deploying applications using OCI DevOps service is to create a DevOps project. A DevOps project is a logical grouping of DevOps resources needed to implement a CI/CD workflow. As part of creating the project, you will create private repositories, code repositories to store and manage source code. You'll also create OCI artifacts and container registries to house artifacts to be used in deployments. Then you'll go on to create environments. These acts as a reference to the OCI compute resources to which artifacts are deployed. It could be a function application, a group of compute instances, or a container engine for Kubernetes cluster. Next, you'll have to create build pipelines where you can define a set of stages for the build process like building, testing, and compiling software artifacts and delivering these artifacts to OCI repositories and optionally triggering a deployment. Next, create a deployment pipeline where you can define sequence of steps for deploying a set of artifacts to the target environments. In order to manage users and pipelines access to DevOps resources, you'll create IAM dynamic groups and policies, something we covered in our previous lesson. You will have to set up a notification topic and subscription that will publish important messages about the project events. Project notifications keep you apprised of important events and the latest DevOps project status. They also alert you if you need to take any necessary action, such as approving a workflow. You must enable logging, as DevOps services use the OCI logging service to record the output it generates during the pipeline runs. This means that the build logs are available for use in other OCI toolings. Remember, creating a DevOps project does not have to be done in one particular order, but resources like repositories, registries, and environments must be created before the build and the deployment pipelines can be created. Let's take a look at the benefits of using DevOps project. DevOps projects lets you keep track of all your software delivery lifecycle resources in one place and share them easily. It enables faster software delivery, as using DevOps project reduces the change-driven errors and decreases the time customers spend on building and deploying releases manually. It helps you enhance security and reduce risk in delivery. Automation mainly reduces the chance of human errors that might introduce a security vulnerability. Security bugs can be resolved quickly by rolling out a fix in time. DevOps project provides the feature to enable logging, monitoring, and notification for all your DevOps resources. DevOps logs emit all the DevOps project resources logs, which can be used for troubleshooting and optimally managing OCI resources. You can create a DevOps project in the OCI console or by using an API or command line interface. Let's understand the code repositories in detail. Code repositories are centralized code creation, version control, and management systems. They archive previous stages of code and related documentation. Code repository branches are localized copies of code that developers can check out to work on without impacting other developers. This allows for multiple users to edit code simultaneously and check their changes before merging them into the main code branch. Code repositories have strong version control and collaboration capabilities that are critical for DevOps because DevOps workflows include frequent and small code changes. Within the DevOps project, you can create your own private code repositories in the OCI code repository, which is like Git. To grant users permission to access your code repositories and other resources, you must create an IAM policies. Now, once you have an OCI code repository, you can clone it using HTTPS or SSH to create a local copy, add or remove files, commit changes, and work on different branches using Git operations. Remember, an OCID is assigned to the repository upon creation, and make a note that you pay only for the storage and no additional charges are to be paid for the repository. You can also edit, clone, and delete repositories or mirror an external code repositories such as GitHub, GitLab, Bitbucket Cloud, Visual Builder Studio, Bitbucket Server, and GitLab Server. Now, remember, before creating the external connection in order to mirror an existing code repository, you must store the tokens or credentials in OCI Vault for authentication purpose. So in order to mirror third-party repositories which are hosted on GitHub Enterprise Cloud, GitLab SaaS, GitLab Servers, and Visual Builder Studio, you will have to retrieve a personal access token, also known as PAT, from those providers and store your personal access token securely in an OCI vault. In case you want to mirror a Bitbucket cloud, there you need your Bitbucket username and create an app password which should be then stored in an OCI vault. And for Bitbucket server, you'll have to create an HTTP access token and then store the access token in an OCI vault. After you define an external connection, changes to your existing Git repo are automatically replicated in the OCI code repository. Code repositories are mirrored every 15 minutes by default, but this can be customized. Mirroring your external code in the OCI code repository speeds up the build process, as the code is retrieved from an internal location rather than from a server which is farther away. To wrap up our discussion, in this lesson we understood the benefits of OCI DevOps offering and covered OCI DevOps services like DevOps Project and Code Repositories. Thanks for watching. Hi, I am Mahendra Mehra, and as part of this demo, I'll be showing you how to create a DevOps project. A DevOps project is the core starting point for DevOps activities within OCI. It contains pipelines, information on artifacts, and of course, an OCI code repository. We will divide this demo into two tasks. The first task is to create notifications topic used for the DevOps services elements to communicate between themselves. And the second task would be to create the DevOps project. So let's jump to the first task. Okay, so I am in my OCI console, and to start with the first task, click on the hamburger menu, go to the developer services and select notifications under application integration. Once you're on the notification page, make sure that you have selected the right compartment on the left hand side under the compartment selector. In our case, it's CTDoc. Click on create topic to open the create pop-up and fill up the form details like name, description. I have filled up the name as DevOps topic and the description is communication between DevOps service element. Click the create button. It will take some time for the topic to be created. Once it has, you will see it in the topics list. As you can see, the topic that I created is listed over here and the state of the topic is active. With this, we are done with our first task, and now let's move on to the second task of creating the DevOps project. To navigate to the DevOps service, click on the hamburger menu, go to the developer services, and under the DevOps, click on overview. Here you can click on the create DevOps project button and the pop-up will ask you to fill a few details. You can provide a name for your project and a suitable description. Let me quickly go ahead and fill this. Okay, so I have given the project a name DevOps project and given a suitable description for it. Next thing that you need to do is click on select topic. This will open up a new topic selection pop-up, and in the topic selection pop-up, make sure that your compartment is selected and you choose the right topic. In our case, the compartment is CTDoc and the topic is DevOps topic we just created in task 1. Click on the select topic button. The topic selection pop-up will close. Confirm the details on this page. Once you confirm the details, click on create DevOps project. After a short while, the project will be created and you will be at the main page for your newly created project. Alright then, you are at the main page of your DevOps project. We can see that it is notifying us to enable log for the project. Ideally, the DevOps service uses the OCI logging service to record the output it generates during the pipeline runs. This will mean that the build logs are available for use in other OCI toolings. So go ahead and click on enable logs. This will take you to the log management page. And as we can see, the enable log is disabled. Click the toggle to enable the log. In the pop-up, you can see there are different fields. You can change the log name if you wish to. For me, I'll be changing it to demo. And then once all the details are confirmed, you can click on enable log button. Once you click on the enable log button, the logs will go through the creating stage to the active stage. At present, our log is in the creating stage. As you can see now, the logs are active. Now use the breadcrumbs to go to your project's home page by clicking on the DevOps project and select the DevOps project. Now you see that the enable logging warning is no longer there. That's it. We are now ready to start using the DevOps project. See you in the next demo. Thanks for watching. Hi, I am Mahendra Mehra, and as part of this demo, I'll be showing you how to configure a SSH authentication token. One of the ways you can authenticate to access Oracle Cloud Infrastructure Services is using a SSH-based API key. In this demo, I'll show you how to do it. This demo is divided into 3 tasks. The first task is to create a SSH key pair. Later, we'll be taking the public key and converting it into PEM format so OCI can process it. The next task is to upload the public key to OCI to use as token. And the third task would be to configure our SSH environment to use this key when connecting to the OCI code repositories, which we will be creating later. Okay, so I'm back to my OCI console. And for the first task that we have to do is to create an SSH key pair. For this demo, I'll be using the Cloud Shell to interact with the OCI services. Let's start the Cloud Shell by clicking on the shell icon from the top right corner of your OCI dashboard. This will create your Oracle Cloud Shell machine and connect you to it. Alright, so I have the prompt and now I'll start using the Cloud Shell for the remaining tasks. Okay, so before we create the SSH keys, we need to create a .ssh directory to hold those keys. In my case, the SSH directory already exists. In case you don't have it, you'll have to create it using the mkdir command. Let me quickly show you my .ssh directory. Here it is. Let me go to my SSH directory. And as you can see, I already have a public key pair created. But for the demo purpose, I'll create new ones. If you're working with the Cloud Shell for the first time, then in your case, it will be an empty directory. Let's create an SSH key pair using the ssh-keygen command. This is the command that helps you create the SSH key pairs. For me, it's asking me to overwrite my previous keys. Of course, I will say a yes to overwrite them and leave the passphrase as blank. Just hit enter again. Alright, my new SSH key pairs have been created. Make a note that you have to provide the email address while creating the SSH key. This email address is the email address for your users that you have created. And if you're using a free tier account, it will be the email address that you use during the sign-up process. Now we need to get the public part of the key into the PEM format so OCI can process it. Before that, let me quickly clear my screen using Ctrl L. Now let's see the command to convert the public part of the key into PEM format. This is the command that we'll have to use. Hit enter. And the output is the PEM format of our public key. You need to make a note of this resulting text right from the first hyphen till the last and just copy it somewhere so that you keep track of it, because this will be required in the later task. Once we have this key created, let's go to our next task, which is to set this key as an API key in our Oracle account. I have hopped on to a new tab to set up the key generated in the Cloud Shell as an API key in my Oracle account. To do so, click on the profile icon on the top right corner and click on your username. When you click on the username, it takes you to the user details page and it shows the username at the top. Of course, this will be different for you. Scroll down and go to the API keys sections under the resources. Click on the API keys. Make a note that if you already have 3 API keys, you cannot add more than 3. So in that case, you'll have to delete one to add a new API key. In my case, the list is empty, so I'll go on to add a new API key by clicking on the Add API Key button. Since we have the key already with us, we'll be pasting it out here. Choose the Paste Public Key option and paste the public key on this box. Alright, I've added my public key over here. Click on the Add button. Once you click on the Add button, the UI will show you a confirmation box. Click the Close button and the UI will update to show the summary info for the newly added key. As we can see, the list has been updated and we have the first key in our list which we just added. The next step is to update your SSH configuration file. In order to edit your SSH configuration file, you need to know a few information. For that, we must know the username and the tenancy information. To get a hold of those information, click on the user profile menu. And as you can see, we have the username and the tenancy information right here. Just make a note of these two information because they will be needed to populate your configuration file. So if you're doing it for the first time, you might not have the config file in your .ssh directory and you'll have to create it. You can use editor of your choice to create the config file under .ssh directory. This is the command to open the config file. In case you don't have it, it will be created for you. I had previously worked with the config file, so I have the entries already within it. You have to ensure you have similar entries within your config file. Only thing that changes is your username and the tenancy information. In my case, it's mahindra.mehra@oracle.com, which is my username. And this is my tenancy information, which is int Oracle Rohit. And you need to separate them using an @ symbol. So after ensuring that you have these 3 lines with your specific data in it, save the file. Alright then, we are now ready to access the OCI services using the SSH keys we just configured. I hope you liked the video. See you in the next demo. Thanks for watching. Hi, I am Mahendra Mehra, and as part of this demo, I'll be showing you how to configure a code repository within your DevOps project. For this demo, we have 4 tasks to be done. The first task is to create a Git repo in your DevOps project, also called as OCI Code Repository. The second task would be to transfer the sample project from your existing GitHub account using Git to the OCI Cloud Shell environment. The third task would be to use Git to upload the sample code that we downloaded in the step 2 to the OCI Code Repository in your DevOps project. The fourth and the final step would be to have a look at the code in the OCI Code repo and explore other features. So let's get started. Alright, so I've logged into my OCI console. And to start with, we are going to create the OCI Code Repository in your project. If you're not already there, navigate to your DevOps project homepage. So click on the hamburger menu, go to the developer service, click on the projects under DevOps. And on the DevOps project page, select your DevOps project. And on the left side, you can see we have something called Code Repositories. Click on the Code Repositories. So we are on the Code Repositories page now. Here we have 2 options. One is to create repository and one is to mirror an existing repository. We will be looking at mirror repository in the next demo. For the current demo, we'll go ahead with creating our own repository. So to do so, click on Create Repository. The Create Repository UI pops up. Now we need to provide the name, some description to it, which is optional. And again, you can also optionally provide the default branch for your repository. Let me quickly go ahead and populate this data. Okay, I've filled the required details. The name to my repository is Cloud Native Storefront Helidon, and the description is Mahindra's DevOps Lab Repo. I've left the default branch as blank. I'll go on to click Create Repository. It will take a short while to create the repository. then you will be taken to its homepage. That's it. So our repository is created and this is the homepage for our repository. So the homepage of your repository gives details about the repository, details like OCID. So every repository is assigned an OCID. You get to see if the repository was mirrored or not. In our case, we created a new one, so the mirrored says no. Currently, we have just one branch on the repository, which is the main branch. And as you can see, it says you must edit your SSH configuration file to specify the user and key to use for the git clone operation. This is something that we already did in our previous demo. And in order to clone this particular repository on your local terminal, you can use the git clone command given at the bottom. Okay, so for the demonstration purpose, I'll be using this public GitHub repository, which has a storefront microservices created with Helidon. The storefront microservice is an example of microservice that is used in number of Oracle labs, right? And what we'll be doing is cloning this GitHub repo on the OCI Cloud Shell. So let me quickly copy the URL and jump onto the Cloud Shell. Let's quickly clone this. We will be using it to download the sample code from the repository. Alright, so we have cloned the repository. Let me quickly check if we have the files. Right, so we have the directory as Cloud Native Helidon Storefront. This is where our sample codes reside. Let me get inside this directory. And here are our sample codes. We need to tell Git who we are so it can track who makes the changes to the code. So let me add my user email using the git config command, followed by adding the username. We are only setting these for this specific project. Do not worry, doing this will not affect any other Git projects you have in the OCI Cloud Shell. Git operates on the idea of branches. Like a tree, there is a main branch and then the sub branches. Each branch has its own view of the file structure based on what the parent branch looked like when the sub branch was created. It's regarded as a good practice to do your development in a sub branch and make sure it's all working fine before merging your changes into the main branch. We need to tell Git where the OCI code repo is in your project. For this to work, you must have set up SSH keys in your account and updated the .ssh/config file as described in the SSH setup demo. Now switching back to the OCI code repository page for our newly created repo, we will have to use the clone button to copy the clone link. Click on copy to copy the string with clone with SSH. Close this box. Go back to the Cloud Shell. Now we are going to create a connection to the OCI code repository that we just created. This will be called DevOps. In the OCI Cloud Shell, type the following. Just hit enter and this command will not return any output. Let's confirm that we have made the changes and added the Git repo by checking using git remote. As you can see, we have the repository added under the name DevOps. Let me clear the screen. Now let's push our active branch to the code repository on OCI using the git push command. Now the push has been complete. We can see if the files are getting reflected in the OCI code repository. Let's move on to our OCI console and just quickly check if the files are available. Great, we can see the files that we just pushed are available in the OCI code repository. You can explore several options available in the OCI code repository. For example, commits. Commits will list all the commits made into the code. Over here, you can also compare different branches if you wish to using the compare feature. You can see the number of branches that are available within this particular project. In our case, it's only one, that is the main branch. You can also check the git tags if you have specified any. In our case, it will be none. Let's have a look at the state of our project's OCI code repository. So click on the files and we can see the root code of our project. Click on the Helidon storefront full directory. We can see that there are multiple files in this directory. Follow the link to the release sources.java file under src main Java, Com, Oracle, Labs, Halidon, Storefront, Resources. Let me open the status resource.java file for you. If I scroll down, this is the code that is run when the /status REST API is called. Note the line public static string version equals to the version number. This is the version string that is returned when we call the /status endpoint. And as we go through the entire demo, it's what we will be changing to show the CI/CD process has worked. So just keep a track of this version. Using the breadcrumb at the top of the code display, return to the Halidon storefront full directory. Click on the YAML directory. Click on the build directory, and you will find the build spec file present over here. This file will be discussed in more detail in the upcoming lessons. But remember, this is an important file that you will be needing to manage your build pipelines. The ideal location for this file must be your root directory of your project. You can also have it elsewhere, but then you have to make sure that you provide the relative path while creating the managed build pipelines. As you can see in our case, the build_spec.yaml file is present within the YAML/build directory structure. For the sake of simplicity of this demo, I will be moving this file to the root directory. Also, I will be making changes to the version number in the status resources.java file so that we can keep track of the version changes as and when the builds run. As I'm about to make these changes to the code, so let's create a new Git branch to hold these changes so that we don't modify the underlying main branch. Let me hop on to the OCI Cloud Shell and quickly create a new branch. Just making sure that I'm in the project's root directory. I'll be creating a branch my-lab-branch using the git checkout command. The moment you hit enter, you are automatically switched to the new branch that you created. You can check the list of the branches that you have in the current project using the git branch list command. As I hit enter, I can see that there are two branches now in this project. One is the main branch and one is the newly created my-lab-branch. And I'm currently in the new branch that I created. So I'll be making all the said changes in this branch, and then later we'll be pushing this branch to the OCI code repository. So to keep this demo short, let me pause this video and quickly make the changes. Okay, then I have made all the necessary changes. Now let me quickly push the MyLab branch to the OCI code repository using the git push command. Okay, the push has completed successfully. Let me take you to the OCI code repository to see if the changes have taken effect. At present, I am on the OCI code repository, the Cloud Native Storefront repo. And here, as you can see, I'm currently pointing to the main branch. Now, if I click over here, I should be able to see the MyLab branch as well. Great. Now we can see the MyLab branch. If I click on it, I'll be also able to see the file structure within it. Okay, now as you can see, the build_spec file is in the root directory. Also, I have made changes to the version file in the status resources.java file. We can look at the commits made to this branch by selecting the commit option on the left plane and select the branch for which you want to see the commits. Alright, so these are the few commits that I made while I was making those changes. And you can see the recent commit was to move the build spec file from YAML directory to the root directory. I also made changes to the build spec file where under the vault variable section, I added the vault secret OCID for the vault variables declared. Although this won't make any sense to you right now, but you will understand them as and when we progress through the demos. Let me also show you the commit that I made to change the version number in the status resources.java file. So if I click on the commits in the breadcrumb, it will take me back to the commits. And I need to select the branch for which I want to view all the commits. So the commits I want to view is for the MyLab branch. And here is the commit where I have made the change to the version string. And I've changed it from 0.0.1 to 1.0.0. Just keep a track of this version number that we have changed. This will be useful when we will be covering the build and the deployment pipelines. That's it from the demo on OCI Code Repositories. I hope you enjoyed the demo. See you in the next demo. Thanks for watching. Hi, I am Mahendra Mehra, and in this demo, I'll be showing you how to mirror your existing code repositories from GitHub or GitLab to OCI code repositories. This lab is divided into the following tasks. The first task would be to create a personal access token from your existing GitHub account. Later, we will be storing that personal access token as a vault secret. We'll also need to create dynamic group and IAM policies to access the contents of those vault secrets. And then we will be creating a mirror code repository using the OCI code repository DevOps service. And at the end, we will be accessing the mirror code repository. So let's get started. Okay, so I have logged in into my GitHub account, and as part of this demo, I will be mirroring my simple web app repository into the OCI code repository. So to begin with, I need to generate a personal access token. To do so, click on your user profile, go to the settings, scroll down to the developers setting, and on the left hand side you will see something called personal access tokens. Click on the personal access tokens. It will bring you to the personal access tokens page. Now you can click on the generate new token button over here and fill the following details for the new personal access token. You can also set the expiration date for the token. From the drop down list, you can choose 7, 30, or you can also provide your own custom date when you want the token to expire, or else you can also select no expiration if you don't want the token to expire. So I'll leave it to the default. Next thing that you have to do is you have to define the scopes that will provide the access for the personal access tokens. For the simplicity of this demo, I'll select all the scopes. And click on generate token. Alright, so our token is generated. You need to save this token somewhere so that you can use it later in the OCI Vault service. So let me quickly copy the token and save it somewhere. Okay, then let me go to the OCI console and let us create a secret for this personal access token. To do so, click on the hamburger menu, go to the identity and security service, and here click on the Vault service. Make sure that the compartment selected is CTDOG or the one that you've been using for your DevOps project. Here, as I said in the previous demos, that I have already done some prerequisite tasks. One of it is that I have created the vaults where I'll be managing all the secrets. So DevOps is part of that prerequisite that I've already configured. Let's go to the DevOps vault. Over here, I've already configured the master encryption key, which is my key. And then let me take you to the secrets tab. Within the secrets, we specify all the secret values that we wish to store. So over here, let's quickly create a secret for our GitHub personal access token. Let me click on create secret. When you click on create secret, the create secret pop-ups comes up and you'll have to provide the other details like name, description, and the encryption key, etc. and the secret key content. So let me just give it a name. Let me give it a description. Let me select the master key and let me paste the token over here. Alright, click on create secret and you will see that my new secret is getting created. Currently it's showing that it is in the creating state. Once created, it will turn to active. Awesome. As you can see, the secret has been created and it has been set to active. Now we will be using this secret to mirror an external repository in the DevOps project code repository. Now before we go and create the mirror code repository, we must ensure that the required dynamic group and the IAM policies are in place for the DevOps connection that we'll be creating to the external repository. If you recollect from the IAM policies demo, I've already created a connections dynamic group and created a policy for the same. Let me quickly take you to the identity and security service and show you the dynamic group and policies that we created earlier. Let me click on the dynamic groups. And if you see, I've already have a dynamic group called connection dynamic group. To click on it, this dynamic group represents the DevOps connection resource type, right? And again, if I take you to the policies, we have a policy in place for this dynamic group. So policies were written for the parents compartment The parent compartment to CTDoc, if you remember, is Mahindra. Let me go to the Mahindra compartment. And now if you see over here, we have this connection dynamic group policy, which is specifically written for the dynamic group, connections dynamic group. And if I go to the policy is written for this dynamic group to read the secret family in the compartment CTDoc. So the secret family is basically the vault service and the secrets mentioned within the vault service for all the secrets that are present in the CTDoc compartment. So as we are assured that we have the required dynamic groups and their associated policies in place, let us quickly jump to the DevOps project and start creating a mirror repository. To do that, click on the hamburger icon, go to the developer service and click on projects in the DevOps. Here, this is our DevOps project that we had created. Let's go to the code repositories. We can see there's one code repository that already exists, which we created in the previous demo. In this demo, we'll be doing mirror repository. So like I mentioned that I will be mirroring a simple web app repository from my personal GitHub account. Let me click on mirror repository. All right, so you'll have to create a new connection. Specify a name for the connection. Give it a description. The type of connection is GitHub, but you can choose from several others like GitLab, Bitbucket Cloud, Visual Builder Studio. So let me select GitHub. Let me now provide the secret key to this particular connection. That is the personal access token that we generated. So let me select the vault name, which is DevOps. And once the vault is selected, it will show you all the secrets present within it. You need to choose the one that you created using the personal access token from the GitHub account. So what we did is we created GitHub pat_demo_1. Let me select that and click on create. If everything goes well, this repository field over here will populate all the repositories present in my GitHub account. As you can see, all my repositories are populated over here. Now I may choose one that I wish to mirror. So we'll be selecting the simple web app. Now within the mirroring schedule, you can choose the scheduling type. That is, when do you want the mirror to be synchronized with your code repository? So you can go for the default value, which is basically it will synchronize every 15 minutes and make sure that the changes made to your GitHub account are reflected in the code repository. Otherwise, the other options that you have is once. When you select once, it will only automatically synchronize once when this mirror repository is created. The third option that you have is of custom, where you can define the time within which you want the mirror to be synchronized. For this demo, we'll be selecting it as 2 minutes, as I'll be making changes to my GitHub repository and I'll be showing you that those changes are reflected back to the OCI code repositories. Let's keep it to 2 minutes. All right, you can also give a name to your code repository that you are mirroring over here. So I'll leave it as default and leave the description blank as it's optional. Click on mirror repository. It will take some time before we can see a new repository getting created with the name GitHub_simple_web app. Let me do a quick refresh on the page. Great. As you can see, our mirrored repository has been created and the status says it's mirrored, right? Let me quickly go into this repository and see if we can see all the files. Okay, so I'm in the mirrored repository and as we can see, there are 4 files currently present within this repository. Let me take you to my original GitHub account, which we mirrored, and let me show you the files that are present within the repository that we mirrored from. So this is the repository that we mirrored, which is simple web app. If I click on it, you can see there are 4 files which are exactly the same present in the mirrored repository. Also, to show you a demonstration on if I make some changes in my original repo, will those changes be mirrored back into the OCI code repository? Of course, since we have enabled the synchronization, mirroring synchronization, and we have kept the time limit as 2 minutes, so that every 2 minutes it will check for any changes. Let me quickly add a new file over here. Let me give it a name called testing_2. Alright, let me quickly commit this new file. Great. So as you can see in my current GitHub repository, I have 5 files. Testing_2 is a new file that I just created. Let us see if this new file gets reflected back into the OCI code repository. As we have set 2 minutes time for mirror synchronization. Let me quickly do a refresh on the page to see if we can see a new file within the list. Let me scroll down, and as you can see, a new file has been added to the list of files in our mirrored repo. Testing_2 has been added. Right? If I click on this file, let's just check the contents. This is exactly the same content that we had written in the testing_2 file on our original GitHub repo. So with this, we are done with mirroring the code repo demo. I hope you enjoyed the demo. Thanks for watching. Welcome to the lesson on validating external connections in OCI DevOps projects. I am Mahendra Mehra, your senior OCI instructor with Oracle University. In this short lesson, we'll provide an overview of this new feature, discuss its purpose and importance, and highlight any limitations. Let's dive in. The purpose of validating external connections is to ensure the continued functionality of your connections. Personal access tokens have expiration dates, and it's easy to forget them. By validating external connections, you can verify if the personal access token is still active or has expired. This helps prevent issues during build processes and ensures smooth operations. Validation plays a crucial role in maintaining successful build processes. By verifying personal access token authorization and access to selected repositories, you can avoid potential errors and ensure that your builds run smoothly. This is essential for maintaining efficiency and productivity in your DevOps workflows. It's important to note that validation is not applicable for connections to the GitLab server and the Bitbucket server. To validate external connections in OCI DevOps projects, follow these simple steps. Firstly, open the navigation menu and click Developer Services. Under DevOps, you must select the projects. From the left side menu, navigate to the External Connections options. Select the external connection that you want to validate and then click Validate Connection. Once validation is initiated, you will receive an outcome message. If the validation is successful, a confirmation message will be displayed. However, if the validation fails, you will be notified of the failure. In case of failure, it's important to generate and securely store a personal access token in an OCI vault. By following these steps, you can ensure the smooth functioning of your external connections in OCI DevOps projects. To wrap up, in this lesson we covered the process of validating external connections in OCI DevOps projects. This involved ensuring the functionality of personal access tokens and verifying proper authorization for repository access, thus facilitating smooth operations within the DevOps environment. I hope you found this lesson useful. Stay tuned for the upcoming demo on this newly introduced feature. Thank you for watching. Hello and welcome to this demo on validating an external connection within OCI DevOps project service. I'll switch to the OCI console. I've already logged into my OCI account and this is my OCI dashboard. Now before we begin, let me provide a bit of context. I already have an existing DevOps project where I have configured an external connection with my GitHub account. I'll first navigate to the DevOps project using the hamburger menu, go to Developer Services and click on Projects under DevOps section. This is the DevOps project that I'm talking about. I'll click open this DevOps project. And if you notice, I have already mirrored a code repository within this DevOps project from my GitHub account. The repository name is OCI DevOps Deploy Instance Group, which has been mirrored in this DevOps project. And this was done using an external connection that I had created earlier. This is the external connection using which I was able to mirror the GitHub repository within OCI DevOps project. However, it seems that the existing personal access token used for authorization has expired, leading to a failed validation of the external connection. I'll go to the external connections using the resources menu. I'll click on external connections. I'll open up the external connection by clicking on the connection name. As you can notice, there is a validate connection button that's available, which helps you validate your personal access token configured within this external connection. I'll click on the validate connection button. And as you can see, it says the validation result updated, and the validation results say that it has failed validation. And the message reads, the connection validation failed due to invalid personal access token. Now, how do we resolve this issue? To resolve this issue, we'll have to generate a new personal access token within my GitHub account and store it as a secret in the OCI vault. In the interest of time, I've already created a new personal access token within my GitHub account. To create a personal access token, you simply need to click on your profile and go to Settings. Scroll down and click on Developer Settings. Within Developer Settings, you must click on Personal Access Tokens and click on Tokens Classic. Now, if you notice, the earlier token that I had created had already expired, and this is the new token that I created for this demonstration. I have already saved this token as a secret in my OCI vault. I'll head back to the OCI console. I'll duplicate my OCI console and we'll go to the OCI vault service. I'll click on the hamburger menu, go to Identity and Security, and under the Key Management and Secret Management section, I have the Vault service. I'll click on Vault. GitHub Pat is the vault where I've created the secret. I'll click on GitHub Pat. And I'll click on the secrets under Resources section. As you can notice, there are 3 secrets that are available for the personal access token for my GitHub account. VS01 and 02 are the secrets which are holding personal access token that have already been expired. And VS03 is the one with the latest personal access token and which is still active. Now let's jump back to the first tab, and here I'll click on Edit Connections. And as you can notice, the secret that the connection is referring to is one of the older personal access tokens which has already expired. Now from the drop down, I'll select VS03, which, like I said, holds the current personal access token in the form of secrets and is still active. I'll click on Save Changes. Now that I've made all the necessary changes, let's validate the external connection again. I'll click on Validate Connection button. Alright, this time the validation of the external connection passes successfully, and the last validation result section says Pass. With this, we come to the end of this demonstration where we explored how to validate external connections in your OCI DevOps project to ensure the personal access token used is still valid. I hope you enjoyed this demonstration. See you in the next one. Thank you for watching. Hello and welcome to this lesson on artifacts and registries. So let's get started. An artifact is a reference to any binary, package, image, or other files that make up your application, which is deployed on target environments. They are used to specify software package versions for deployment and must be defined with parameters like name, type, and location before a build is run. OCI has two types of registries for storing, sharing, and managing artifacts. Container Registry, also called Oracle Cloud Infrastructure Registry or OCIR, is an open standard-based Oracle managed service that stores multiple versions of Docker or other container images, plus related files like Helm charts. These images can be pushed to a Kubernetes cluster for deployment using OKE. Container registry was covered in greater detail in the previous module. So let's discuss the other type of registry, that is the artifact registry. Artifact registry is a placeholder for a software package, library, .zip file, or other types of files used for deploying applications. These files are fetched and used when the deployment pipeline is triggered. So let's look at the artifact registry in more detail. This slide will cover the concept of artifact registry, which will help you manage your artifacts. The first point is the repository and artifact names. When you create a repository to group similar artifacts, you give it a repository name. If you leave the name blank, the system automatically generates a name that you can change later. When you upload an artifact to a repository, you specify a path and version for it. Based on your input, an artifact name is assigned that combines these two elements, as you can see in the example over here. Note that slashes do not create a directory structure, but you can use them to organize the repository. Versioning. Because of incremental updates to artifacts, you can assign versions to artifacts. This way, you can associate builds with artifacts version and roll back to previous versions when required. Immutability. When you create a repository, you can designate it as immutable, which means that the artifacts uploaded to it becomes immutable. These artifacts are used as is and cannot be replaced. Immutable repositories ensure the integrity of the artifacts it manages. This means that rollbacks will always use the exact file from the last working version of the deployment and ensure that a developer's code change does not affect code created by others. Note that if you delete an immutable artifact, you cannot assign its name to another artifact. Service limits. In each region that is enabled for your tenancy, you can create up to 500 repositories in artifact registry, consuming a maximum of 500 GB in total. You are charged for the stored artifacts only. You can also integrate external artifact registries with your OCI DevOps. You can create references to these four types of artifacts in OCI DevOps. All but the container image can either point to an artifact registry or can be defined inline. Let's try to understand each one in detail. Container image repository. It's a collection of related container images which is used to manage different versions of an application. Deployment configuration is a YAML file that defines the artifacts for deployment and their locations to fetch them from. Kubernetes manifest. It's a specification of a Kubernetes API object that describes the desired state of an object that Kubernetes will maintain when you apply the manifest. General artifacts. General artifacts include file types like binaries, zip files, or other files. To wrap up our discussion, we understood the types of artifacts and discussed the two OCI registry services which are used to manage them, with emphasis on artifact registry and its key concepts. Thanks for watching. Hello, I am Mahendra Mehra, and as part of this demo, I'll be showing you how to create and manage container registry as well as create and manage artifact registry. So let's get started. Okay, so I am in my OCI console and using the Oracle Cloud Infrastructure Registry, also known as Container Registry, you can create an empty repository in a compartment and give it a name that's unique across all compartments in the entire tenancy. Once you create the repository, you can always push an image to the repository using the Docker command line interface. So to create a repository in the container registry, click on the hamburger menu Go to the Developer Services, click on the container registry under Containers and Artifacts. To start creating a repository, you must first ensure that you have selected the right compartment where you wish to create the repository. In our case, it is ctdoc, so it's by default selected. You can always use the drop-down to choose the right compartment. Now click on Create Repository. The Create Repository dialog box opens. Here, you'll need to ensure that the compartment selected is the correct compartment. For our case, it is ctdoc, and give repository a name. Okay, so I have selected my name. And if you see, the slash over here is not part of the directory structure. It is within the name of my repository. Next, you have to choose the access method. You can either select private or go for public. By default, the access to a newly created repository is private. You can make it public only if you are the administrator of your tenancy, or you belong to the administrator group of the tenancy, or you have the repository managed permissions. If you make the repository public, any user with the internet access and the knowledge of the appropriate URL will be able to pull the image from the repository. If you make the repository private, you, along with other users belonging to tenancy's administrator group, will be able to perform any operation on the repository. Since the user that I am working with is part of the administrator group and I have given him the repository managed permission, I'll be selecting the public access option and click on Create Repository. Alright, as you can see, my repository has been created. Currently, there is no image present in this repository. I can always use a Docker CLI to push Docker container images into this repository. You can select the repository and then you can click on the Actions tab on the top right corner to either delete the repository or move this repository to another compartment. Okay, so with this we have learned how to create a container registry using the OCI console. Okay, so let's move on to create the artifact registry. In order to create the artifact registry, we can click on the artifact registry option given on the left hand side. Or if you wish to go to it through the hamburger menu, you can always click the hamburger menu, go to the Developer Services and click on the artifact registry within the Containers and Artifact option. So I select the artifact registry, it brings me to the same page. Now in order to create an artifact registry, you must ensure that under the list scope, the compartment that you have selected is the right compartment where you wish to create the artifact registry. In our case, throughout the demo, we've been using ctdoc compartment to manage our DevOps resources, so we'll leave it default. Now click on the Create Repository button. A Create Repository dialog box appears where you can specify the name of the repository, the compartment where you wish to have it. Then you can also select whether you want to have it as an immutable artifact or mutable artifact. If you check this option, it makes it an immutable artifact. So if you select this option, any artifact that you add to this repository can't be changed. And also if the artifact is deleted being immutable, then another artifact with the same name can't be added to this repository. If you unselect this, it makes the artifact mutable and you can have as many revisions of that artifact within this repository. Alright, so I'll quickly update the details here. Okay, so I have updated all the data. The name of my repository is DevOps. The compartment where it will be created is ctdoc. I have unselected the immutable artifact field and the description is given. So let's click on the Create button to create the artifact registry. It brings you to the artifact registries page, and as you can see, my artifact registry is now available. Currently, there are no artifacts present in the artifact registry. The artifact registry is given an OCIR, which uniquely identifies it. Again, in this particular information tab, you can see all the information related to the artifact registry. If you wish to delete the artifact registry, you can click on the delete button and it will delete the artifact registry for you. Similarly, if you wish to edit any details of the artifact registry, you can click on edit. You can edit the name and the description for the artifact registry and click Save Changes. So as you can see over here, the artifact registry is listed under the artifact registry page and its state says it's available and the creation date. Okay, with this we have come to the end of this demo. where we have learned how to create a container registry and an artifact registry. I hope you liked the demo. See you in the next demo. Thanks for watching. Hello and welcome to this lesson on environments. So let's get started. An environment is a collection of your computing resources where artifacts are deployed. You can also consider them as the target platform for your applications. Different target runtime environments supported in OCI include group of compute instances running Oracle Linux and CentOS, Oracle Container Engine for Kubernetes, and function applications. Before you create references to a target environment, you must first create a target environment if it doesn't already exist in the OCI console. Environment can be created in different OCI region than the region of the deployment pipeline. This allows developers to extend their deployment to multiple OCI regions. Which environment you choose for deployment depends on your needs based on flexibility, security, speed, and several other factors. This graph here helps us examine trade-offs between control, security, and cost with that of flexibility, portability, and speed for the choice of target environments that are available. Let's take a closer look at each environment. Bare metal is the least versatile, most costly option, but it provides the most control and security. It's a good option for projects that require a more constant, larger, or separate and secure space. With virtual machines, different operating systems can run on single machine and VMs can be commissioned and decommissioned more easily than bare metal. This allows for more versatility, scaling, and resource sharing. Shared applications and physical hardware provide cost savings, disaster recovery, speed, and faster provisioning. Each VM still requires its own operating system. This can be a benefit as you can run multiple applications requiring different operating systems on a single piece of infrastructure. But it uses more resources and spins up in minutes, not seconds. Kubernetes clusters runs group of application containers that are portable, lightweight, isolated, and standardized. They contain everything needed to run an application, so you don't need to rely on what is on the host, which speeds up the coding process. They also share OS, bug fixes, patches, and often binaries and libraries, so they spin up more quickly and require fewer IT resources to deploy and manage than VMs, making it ideal for high density environments and for small and medium deployments where you need to do more with fewer resources. Functions. Functions make computing power or backend services available on demand. You only need to select the required managed services. The serverless provider manages the underlying servers so the user can focus on writing and deploying code. Functions also deploy in milliseconds, not seconds, so the application can go live as soon as the code is uploaded. Functions are best with dynamic workloads whose usages change frequently because you're paying for services only as you use them. To wrap up our discussion, in this lesson we covered various options available as target environments to deploy our application artifacts under the DevOps project. We also discussed the trade-offs of using either of these environments. I hope you found this lesson useful. Thanks for watching. Hello and welcome. My name is Mahendra Mehra and I am a senior training lead and evangelist at Oracle, and I will be your instructor for this module. In this module, we will introduce you to the CI/CD DevOps practices and give you a walkthrough of OCI DevOps service named DevOps project. Also, guide you on how to integrate it with other OCI services to help you cope up with the cloud native shift. So let's get started. Here's the overall OCI DevOps structure and the workflow again, which we have been following since our very first module. We are going to focus on these services. The DevOps project, which contains the code repositories, build and deployment pipelines, and artifact registry. Though we had already covered OKE and container registry in our previous module on microservices and containerization, this module will teach you how to automate deployment to these environments. Our focus will be on learning continuous integration, development, and delivery practices that creates a ground for automation that automates repetitive tasks, curtails manual errors, and minimizes the operational cost. Though several other observability and security elements such as monitoring, notifications, logging, vault, and IAM policies are also part of the CI/CD workflow, they will be covered in greater detail in the subsequent modules. A CI/CD pipeline or continuous integration and continuous deployment is the backbone of modern DevOps environment. It bridges the gap between development and operations teams by automating the building, testing, and deployment of applications. Continuous integration is a modern software development practice in which incremental code changes are made frequently and reliably. Automated build and test steps triggered by CI ensure that the code changes being merged into the repository are reliable. This practice mainly encourages small modification in the code over large changes infrequently. Each change in the code activates a build that runs tests to identify any broken parts of the code, as shown in the blue area on the diagram. Continuous deployment, marked on the green area, on the other hand, goes one step further as it allows developers to deploy every piece of their code, be it new features or bug fixes, right up to the production environment, using either an automated continuous deployment or a manual continuous delivery process. Continuous feedback stages like operate and monitor in gray region are also a key part of the DevOps process, which helps you monitor performance, optimize infrastructure, and notify of any potential issues. These services are also covered in the later modules. This diagram best represents the OCI DevOps workflow, right from committing the code changes till its deployment on the live servers. The heart of the workflow is the build and the deployment pipelines within the continuous integration and continuous deployment. The build pipeline follows a user-defined flow to build the code, test the package, and deliver them as a code artifacts in the OCI artifact registry or as ready-to-ship image in the container registry. The deployment pipeline then uses the build image from the container registry and a Kubernetes manifest to deploy the most recent version of the applications to a staging environment. After final test and approvals, the pipeline pushes the image to the desired production environment, which can be a group of compute hosts, a container engine, or a function. This is completely based on the architectural design of the software application. You might also want to move an existing application from on-premises or another cloud service provider to OCI. OCI DevOps as a service provides the flexibility to integrate with your existing CI/CD workflows, thus offering a robust DevOps solution. To wrap up, a CI/CD pipeline automates your software delivery process. The pipeline builds code, runs tests, and safely deploys a new version of the application. Automated pipelines remove manual errors, provide standardized feedback loops to the developers, enables fast product iteration, and delivers the software to the customer faster than ever before. I hope this lesson was useful. Thanks for watching. Hello and welcome to this lesson on build pipelines. In this lesson, I'll cover the DevOps build pipeline structure, build specification file, and prerequisites. We'll then look at the build pipeline stages. So let's get started. Continuous integration is where code is committed, built, tested, and revised more regularly and reliably. Code and build specification instructions triggers test in a streamlined automated process that creates the desired artifacts. A build pipeline contains the stages that define the build process for successfully compiling, testing, and running software applications before deployment. It is the heart of continuous integration workflow. OCI DevOps build and deployment pipelines reduce the change-driven errors and decrease the time customers spend on builds and deployments. As we see in this diagram, the chain of events start from developers who commit source code to an OCI source code repository, which triggers the build pipeline that spins a build runner to execute the build steps. which results in artifact generation delivered to specific OCI repositories based on their types. Build pipeline also has the provision to run a deployment pipeline, which facilitates deploying software artifacts to the target environments. As this lesson is dedicated to build pipelines, let's explore the same. To trigger a build pipeline, you must already have created and configured an OCI DevOps project and its resources, a code repository, and a build spec file. You also need to enable logging capabilities, which helps log the build pipeline activities. A build pipeline is a DevOps resource which needs adequate permissions to manage or interact with other OCI services like reading code from code repository, publishing a container image and deliver it to container registry, and trigger a deployment pipeline. It can inherit these permissions from a dynamic group it belongs to. These can be specifically defined to restrict permissions to one specific build pipeline, one code repository, and one artifact. This is the high-level flow for the build pipeline. We'll look at each step in more detail. Pipelines can be edited to add, modify, or delete stages. You can manually run or automatically trigger a pipeline. You should monitor the progress of the pipeline to ensure its successful completion or debug during failures. To build code, we generally need a set of instructions that tells us what and how to build. Similarly, while creating a build pipeline, you first want to create the build spec file, which is a YAML file. The build specification in this file contains build steps and settings that the build pipeline uses to run a build. Also includes the definition of the artifacts you want to deliver. A build pipeline can have multiple stages to it. We always start with the managed build stage and then extend the pipeline using any of these optional stages to deliver artifacts, trigger deployment pipeline, or introduce wait. Let's look at this process in more detail. The build spec file is a configuration file written in YAML and contains build steps and settings used to run a build. By default, the build specification is in the root of your primary build source directory and is used when you run a build pipeline. If it's not there, you must provide the relative path to the file when adding the managed build stage. The build server will interpret this file and go through the steps that are defined in it. The build specification is organized into 4 sections. Configuration of the build runner. This is the basic information needed by the build system. The build spec version, how long the entire build process should take before it's being stopped, the user running the build, and what shell should be used when executing the commands. Setup of environment variables. This is where the standard, vault, and the exported variables are configured. Steps define how build must progress within a given stage. Every step is defined using a name, a timeout limit, and command to be executed within that step. Command specified in the step runs in the same OS instance but not in the same shell instance. Output artifacts. They tell the build pipeline what the result of the build are and automatically extracts and saves the items specified for use in the later pipeline stages. Environment variables are defined in the build specification file. They can be standard variables which act like any regular variables which can be used in the later steps within the particular build stage. Vault variables are used to manage your vault secrets. These also persist across steps, but they cannot be exported outside the build spec to prevent leakage of confidential information. The exported variables are passed out of the build process to the following stages. Only variable names here are exported. So if you want a standard variable to be exported to a subsequent build stage, you need to specify it here. Several environment variables such as the build run ID or the trigger source name are predefined on the build server itself. You can also create parameters that are set when the pipeline is run using the given syntax, which starts with the dollar symbol and the variable name within the curly braces. Build specification file specifies both input and output artifacts. Input artifacts can be defined in the build specification and supplement the code repositories that drive the build. There are 2 types of artifacts that can be defined here. One is the artifact from any of the previous build stages and other is the artifact from any external downloadable public URL. The build specification file ends with the definition of the output artifacts. These artifacts are referenced in the pipeline stage for automated deployment to the target environments. They are used to specify software package versions for the deployment. DevOps artifacts can be container image, a generic artifact, or they can be defined inline. The artifact source varies depending upon the type of artifact. OCI DevOps accepts 4 types of artifact references. The first is the container image you build. The next two are the YAML files, the deployment configuration file, which defines the artifacts for the instance group only, and the Kubernetes manifest, which specifies the desired state of an object the Kubernetes will maintain when you apply it. The last type is other general artifacts. Each output artifact is given a name that later steps can refer to. A type like binary or Docker image, and a reference to a file or a container image in the local registry. The build spec should have the unique ID for the container that the build is going to create. For target environment like instance group, a deployment configuration file defines the commands and run steps to download an application package artifact from the specified artifact registry and place it in the target compute instance file system. The file can be defined inline or provided as a generic artifact reference during instance group deployment. DevOps admins can use the deployment configuration file to specify application packages and locations where they must be stored in the target compute instance. It can also be used to specify the steps required to deploy an application. Also used to specify user-defined or built-in environment variables required for the deployment. The continuous integration feature of DevOps project provides 4 different stages to create a build pipeline. Managed build. Builds and test your software with OCI DevOps Managed Build Runner. Only this stage is mandatory and it must be the first stage of your build pipeline. Deliver artifact stage publishes your created software packages to OCI artifact repositories. Trigger deployment stage starts a deployment pipeline with the results from your build. And the wait stage allows for a specified amount of time before proceeding to the next stage. It can be used at any point in the pipeline. Let's take a look at each of these build stages in more detail. The managed build stage builds and tests your software with a fast and scalable OCI DevOps service called Managed Build Runner. The job of the build runner is to follow the instructions provided in the build spec YAML file, which includes request to export variables, install prerequisites, compile and package code, and build container images. You can also run several tests in this stage. Each build pipeline must have at least one managed build stage to start with. The deliver artifact stage maps the build outputs from the managed build stage with the version and delivers the artifacts to the OCI container registry and the artifact registry. The artifacts can be either OCI container images or generic universal file types. Make a note, this stage can't be the first one in a build pipeline, as you first need to create artifacts using managed build stage before you can deliver them to a repository. The trigger deployment stage automatically triggers a deployment pipeline from the build pipeline. Before you add this stage, a deployment pipeline associated with your DevOps project must exist. Recall that the OCI DevOps supports deployment to different target environments like OKE, instance group, and functions. The wait stage can be added when the system needs to wait a specified amount of time before moving to the next stage. It can't be added as the first stage to a build pipeline, and the pipeline must have at least one managed build stage first. The duration is given in seconds, for example 300 seconds. During this duration, the build process is paused. Running a build pipeline can be done manually by clicking the Start Manual Run button in the OCI console or automatically using triggers. You can create a trigger in the OCI console for a build which will automatically run a build pipeline on matching source code repository events in either the OCI code repository, GitLab, or GitHub. You can trigger a conditional build by adding the action of an optional event such as a push or a pull request. Make a note, before creating a trigger in DevOps, you must have a DevOps project, a build pipeline, and a code repository associated with the project. The build then gathers and compiles code and associated files from the OCI code repository or mirrored GitHub repos. Runs the requested unit and validation test. Then publishes the resulting container image, logs, and other software artifacts to the OCI container registry and artifact repository respectively. As we studied earlier, the build pipeline can also optionally trigger a deployment pipeline. which takes care of pulling the artifacts and deploying them on the target environments. You can also edit triggers to update their details or delete them. When it comes to managing build pipelines, create, delete, and edit operations can be performed easily using console. You can always come back and customize the pipeline to accommodate changes. Parameters can be configured to supply values to placeholders during the build process. Build pipeline gives you the provision to monitor the progress of each build step and stage on the console, which makes it easier to troubleshoot in case of failures. Note, you can't delete the build pipeline unless you delete all the stages within it. When you create a build pipeline in the OCI console, you select the stages you want the build to include. When the build run starts, the console shows you a graph with a box for each stage on the left. To the right of it is the build run progress, where you can expand each stage to see the steps being taken, the time they take, and the status of each step. These steps are taken directly from the build spec file we provided. On the far right are the log details. During the build run, the active stage is highlighted in the graph. A build run is successful if all the stages in the pipeline complete successfully. When the build run completes, you can view the results in the console's build history section, which houses the status and results of all the previous builds. To wrap up our discussion, in this lesson we covered DevOps project build pipeline feature in detail. We addressed topics like build spec file, which is the main element that structures the build. We also discussed different stage options and triggers to automate the start of build and deployment pipeline. Before I end this lesson, just to let you know that while OCI DevOps itself is a free service, you do have to pay for the build server. Just the pay-per-use, compute cost, and the network traffic to and from outside OCI boundaries. I hope you found this lesson useful. Thanks for watching. Hello, I am Mahendra Mehra, and in this demo, we will be examining the build_spec.yaml file. So let's get started. Okay, so I am currently in my OCI console. Let me quickly take you to the code repository within our DevOps project where we have the build_spec.yaml file. So let me go to the developer services within which we have the DevOps projects. Let me choose the DevOps project that we created, and within which on the left hand side you can see there's code repositories. So let's click on the code repositories. Alright, so the project code is stored in the Cloud Native Storefront Helidon repository. Let me quickly click on it. So if you remember, we had created a MyLab branch to work on. So all the commits that we did was in this branch. So we'll examine the code within this branch itself. So here, as you can see, the build_spec.yaml file is present here, which is in the root directory of my repository. So let me quickly click on it. Okay, so just a refresher, the build specification file contains the build steps and settings that the build pipeline uses to run a build. The build specification file is written in YAML by default, and the build specification is located in the root of your primary build source directory, and it is used whenever you run a build pipeline. Just in case you don't store it in the root of your primary repository, you will have to provide the relative path while creating the manage build stage. Okay, so the first few lines represents the general header of your build specification file, and this content provides the basic information needed by the build system, which defines the version of the build spec used, how long the entire build process should take before being stopped, the user running the build process, and what shell should be used when executing the commands. As you can see, the version is 0.1. The component says it's a build component. It is being run as root user. The shell used is being bash, and the timeout in seconds is 6000. Right? Let's move on to the next section, which is the environment variable section. So in this block, we have three sections. One is for the variables, the another one is for the vault variables, and the third one is for the exported variables. So let's look at the variable section. The variables declared in the variables section persist across different build steps, but do not cross the pipeline stages unless you explicitly specify them or unless you explicitly export them as an exported variables. The next section is the vault variables. The vault variables are replaced with the contents of the vault secrets which we had set up earlier as a prerequisite. So the two secrets that I had configured as part of prerequisite is OCIR host vault and OCIR storage namespace vault. Let me quickly take you to the vault and show you the secrets that I have created. Let me duplicate this tab. Let us quickly go to the identity and security services and click on vault. Right, so I have created the vault DevOps in the compartment citydog. Let's go to the vault and scroll down. If you click on the secrets over here, you can see that the two vault variables are defined over here. The vault secrets are defined in terms of these variables, which is matching the one that we have in the build spec file, right? So the secret is basically defining the encrypted version of the values that we have configured within this vault secret. And in order to specify that, you have to use the OCID of the vault variables or the vault secrets that we have declared. So in that case, what I did is I clicked on copy OCID, and that OCID was pasted over here for the respective variables that we have declared. So the importance of the vault variables is to configure credentials within the build pipeline, but not as plain text, rather use vault secrets to mask those credentials. The vault variables declared persist across different steps within the pipeline, but they cannot be exported outside the build_spec to prevent leakage of confidential informations. The exported variable section, basically the variables declared over here are passed out of the build process to the different stages. Only variable names specified over here are exported. So if you want a standard variable to be exported to a subsequent build stage, you need to specify it over here. So like I mentioned, the vault variables cannot be exported to other build stages, but in case you want to do so, what you can do is you can create another exported variable and pass on the values of the vault variables to that exported variable, which then later on can be used in the subsequent stages. The next section in the build spec YAML file is the steps section. Steps are the individual stages executed by the build pipeline, and they run in the same OS instance but not in the same shell instance. So if you want a variable to persist across steps, you need to specify it in the variables section as I showed earlier. Also note the variables like path are persisted across several sessions and you don't need to specify them explicitly. Each step has a field called name and timeout. Also has a field called command which specified what exactly needs to be done within that stage. So the first step under the steps section is to extract the exported variables. So as you can see here, we are trying to export the version number from the status resource.java file and trying to export it into the storefront_version variable, which was declared under the exported variables. Also, as you can see, we are trying to transfer the value of our vault variables that we had declared into the exported variables. So this is the vault variable and this is the exported variable. Let me quickly show you. OCIR_host is the exported variable and OCIR_host_vault is the vault variable. We are transferring the values into the exported variables, right? And later on, as you can see, we are trying to craft a path using those variables where our image will be stored, right? So every image that will be created is given a version based on the version specified within the status resources.java file, right? And again, you can specify your repository name, but then we are using a placeholder which is defined as your_initials, which we will be seeing in our later demos that how to populate these placeholders by passing parameters. We also have a section of on failure where you specify how to handle failures, but here for the demo purpose we are just echoing a few statements. This is the start of the next step within our build spec file. In this step, what we are trying to do is trying to install all the required softwares. Moving to the third step, where we are trying to confirm all the variables and the versions that are stored into those variables. So this is one way where you can ensure that all the versions and the paths are set up accurately. In the fourth step, what we're trying to do is we're trying to build the source code and pack them into a container image. The last section in the build specification file is the output artifact section. This section tells the build pipeline what the results of the build are once it's completed the steps that we had specified above. The pipeline will automatically extract the items specified in the output artifact section and save them away for later use in the next stage of the pipeline. This could also be another build stage, in which case the build_spec file of the new build stage will have to define input artifacts that matches the one that we have put over here. Make a note that the output artifacts does not only specifies the Docker images that we created in the previous step, but also has the YAML files which represents the manifest for our Kubernetes. Well, that's it from the demo. I hope you enjoyed the demo. See you in the next demo. Thanks for watching. Hello, I am Mahendra Mehra, and as part of this demo, we will be looking at the build pipeline. This demo is divided into following tasks. At first, we will be creating the build pipeline. Later, we will be seeing the build stages. We will also be running our first build pipeline and navigating through the build outputs. So let's get started. Alright, to start with this demo, we need to navigate to our DevOps project's homepage. To do that, we can click on the hamburger icon, go to the DevOps services, and under DevOps, we can click on the projects. Now from the list, select the project that you've been working on. Alright, so as you can see on the projects page, it says that there are latest code repositories attached to this project. Out of these two, Cloud Native Storefront Helidon is where our project code resides. Currently, there are no build pipelines, no build history, no deployment pipelines in the project page. As you can see, they all are blank. We will keep on adding them as and when we move ahead in the demos. Alright, to begin with your build pipelines, you'll have to click on the build pipelines in the resources section on the left hand side. Click on the build pipelines here. You are on the build pipelines page. To start working on your new pipeline, click on the create build pipeline to open the create pipeline pop-up. In the create build pipeline pop-up, give it a name as well as a description, although description is optional. So let me quickly go ahead and populate these two values. Okay, so I have populated the details. My build pipeline name is build storefront and I've given it a valid description. Now I'll click on create to create this pipeline. After a short while, our newly created pipeline is being displayed in the list over here under the build pipelines page. And as you can see, the status of the pipeline is set to active. Again, the pipeline has been assigned an OCID, as you can see over here. You can use this action button over here on the right hand side to perform various operations. Like if you wish to view details, if you wish to edit your pipeline, if you wish to add or view tags, and again, you can also delete the pipeline. But remember, currently there are no stages within the pipeline, so you can very well delete it. But once you have added stages to the pipeline, you won't be able to delete the pipeline until you delete the stages first. Okay, so moving on to our next task, which is to add a build stage. We are now going to add a build stage. Every build stage runs in its build runner, and each build stage has its own runner. Now you can open your build pipeline by clicking on the name, and this brings you to the UI where you can start adding stages. Click on the plus icon to add a new stage and click on add stage. As you can see, there are multiple options available to start creating your build stages, and every option has its description mentioned in the boxes. For the current demo, we will start with the manage build stage. And also remember, a manage build stage is a mandatory stage, that is, it has to be the first stage in your build pipeline. So click on the manage build stage and click on next. This brings you to the manage build stage page where you will have to enter the following details. We'll start with giving it a name and a description. Alright, I have given it a name, build storefront, and the description is builds the storefront. We will leave the agent compute image shape as it is. We will also leave the base container image as it is. This field over here tells you to provide build spec file path. This is optional in case you have not stored the build_spec.yaml file in the root of your repository. So if you have stored it elsewhere, you need to provide the complete relative path to it. The next option here is to provide primary code repositories detail. So click on the select button over here. It opens up the pop-up for select primary code repository, where you need to select the source code connection type. In our case, it's OCI code repository. And from the list that you see, you have to select the one where your project code resides. So our project code resides in the Cloud Native Storefront Helidon repository. I'll go on to select that. Now it asks you whether you want to build the code from the main branch or is there any other branch that you wish to build from. So for the demo purpose, we are using the my lab branch and I'll be selecting that. Okay, so the last field is asking for a build source name. We will give it a name. Now we can click on the save button to return to the stage form. We are back to the stage form. We can leave the timeout blank and click on the add button. Now as you can see on the UI, we have added the first stage successfully and the stage name is build storefront. Once the stage is added, you can always click on the action item and you can either view the details of the stage that you created or you can delete it. So let's click on the view details and it will give you a short summary of your build stage. You can also delete the stage by clicking on the delete button. For now, we will skip this. Okay, so now as you can see in the editor, we have our first stage created. We will go on to run our first pipeline. To run this build pipeline, we'll have to click on the Start Manual Run button on the top right. It brings you to the Start Manual Run page and tells you that the build run will be given a following name. So the build run name is basically the name of your build along with the timestamp. For now, we will leave the parameters as blank and click on the Start Manual Run button. We can now see several aspects on the page. On the left is the build pipeline. At the moment, there's only one stage. But if there were multiple, the color coding would indicate progress with completed stages being in green and in progress stages in amber and the pending stages in gray. In the center section, you will see the list of stages. If you click on the arrow to the left of the stage name, you will see the individual steps in the stage. This corresponds to the steps that we have written in the build_spec.yaml file. As each stage completed, a green check mark will be displayed next to it. Finally, on the right, you will see the logs from the build stages. Note that if there are multiple steps in the build stage, they will all be displayed in the logs for that stage. It can take a while for the logs to start being displayed as they do not update immediately. There can be lag of 30 seconds or more before the data is generated. So the build process can take a few minutes to run. Please be patient. You can also download the logs for the build by clicking on the download button present over here. And if you wish to search for a particular string, you can search the string in the logs by clicking on the search bar over here. So in the meanwhile the build is running, let me also quickly tell you about the different tabs that are present on this page. The very first tab is the build pipeline, which shows you the editor where we created the stage. The next tab is the build history, which shows all the builds that are in progress. This one is the one that is currently running. If I click on it, it will take you to the build run page. Then we have the parameters tab where we can provide the parameters to be passed as values into the placeholders. The work request tab will give you a glimpse of what was done in the past. Like we created the build pipeline, we created the stages, all of that, and it will give you the status of each work that was done in the past. And then you have the tags where you can create tags or define tags for this build pipeline. Alright, let's go back to the build run. And as you can see, the build has been completed successfully and all the steps in our build spec YAML file have been executed. And this is the output in terms of logs, as you can see. If you wish to see the log, you'll have to scroll them using the scroller. You can even download them by clicking on the download button. And as you can see, the build stage ran successfully. So in that case, the build stage over here has been bordered as green. Okay, so let us quickly navigate through the build output by reviewing the log file. Let me take you to the log file that I just downloaded. So this is the log file of the build that we just ran. If you see the log file closely, you will find all the steps mentioned in the build_spec.yaml file are getting executed. So the step like extracting the export variables, where they extracted the version from the status resources.java file and stored it into the storefront_version variable. And the next step was to install local JDK. And as you can see, the JDK is getting installed and the Java path is being set. The next step was to confirm variables and version execution completed successfully or not. And this stage is in action over here. Let me quickly take you to the bottom of the log page where we can see the output artifacts that were generated. So towards the end of the build spec file, we had the output artifact section where it defined which artifacts will get generated. So in our case, it was the Docker image as well as the manifest for Kubernetes. So as you can see, the manifest for Kubernetes and the Docker image that was generated are being managed by the output artifact stage. But remember, we are not pushing these artifacts in any of the container or artifact registry. They are being stored by the build stage somewhere currently, which later we will be utilizing to be pushed into the respective container or artifact registry. With this, we come to the end of this demo. I hope you liked the demo. Thanks for watching.